Since the beginning of our species, we've looked up into the sky and pondered the vastness of the universe. We've counted the stars, charted the constellations, and dreamed of what lies beyond our tiny corner of heaven. But did we ever dare to think about the end? No, not the end of our fleeting human existence, but the end of time itself. What will the last days of the universe look like? What will we see, hear, and feel in those last moments? Will everything go out with a bang, or will something completely unforeseen happen? Throughout history, humanity has thrived on exploring the unknown, pushing the boundaries of our understanding. Today, we embark on the deepest journey, a journey to the very end of time. Like grains of sand in an hourglass, each moment brings us closer to the inevitable conclusion of the universe. But how and when will it happen, and what does it mean for us mere mortal beings? Crossing unimaginable scales of space and time, we travel billions, even trillions of years into the future, a journey not of distance, but of time for the sake of exploring the ultimate fate of the cosmos. A journey to the end of time. Like grains of sand in an hourglass, each moment brings us closer to the inevitable conclusion of the universe. But how and when will it happen, and what does it mean for us mere mortal beings? Crossing unimaginable scales of space and time, we travel billions, even trillions of years into the future, a journey not of distance, but of time for the sake of exploring the ultimate fate of the cosmos. A journey to the end of time. Here we are in the Anthropocene, in the age of man, our time, our era. This is an era defined by the colossal influence of our species on this blue-green sphere we call home. We have shaped, manipulated, and forever altered the very fabric of the Earth in the blink of an eye. Take the Holocene, an 11,700-year era in which all human civilization was born. It has nurtured us from our earliest days, from humble hunter-gatherers to modern, technologically advanced societies. The comfortable climatic conditions of the Holocene allowed us to flourish, to invent, to build. It gave birth to agriculture, to writing. The very notion of civilization, nevertheless, as we rushed forward, the losses on our planet became evident. Our relentless thirst for resources, our relentless expansion caused the changes that marked the end of the Holocene. Climate patterns are changing. Extreme weather events are becoming the norm. Biodiversity is under threat. The equilibrium that has nourished us for thousands of years is teetering on the brink. Our actions have left an indelible mark on the conditions of the Earth and ushered in a new geological epoch, the Anthropocene. This is a chapter of Earth's history written by human hands. As we stand on the threshold of this new era, one question arises: what legacy will we leave to succeeding generations? Our journey brings us closer to the year 2500, revealing the dynamic changes the Earth would face. Earth's magnetic field, our protective shield against solar winds, is undergoing a belated shift. The North and South poles are reversing places, an event last observed 780,000 years ago. This amazing turn is disrupting our technology, forcing us to adapt in ways never before experienced. Let us be transported to the year 4385. We're witnessing the return of an old friend, Comet. Hail, Bob. It is a sight to behold, a bright trail of light illuminating the night sky, a vivid reminder of our place in the universe. Jumping to the year 5000, we're confronted with the grim reality of our past actions. The polar caps have melted, leading to a global sea level rise. Many coastal towns, once full of life, now lie underwater, relics of days long past. In the year 6000, a colossal asteroid looms on the horizon. Its collision with Earth is inevitable, causing a catastrophic event that will change life as we know it. In the year 8000, we're witnessing an extraordinary celestial event. A distant star, having reached the end of its life, explodes in a spectacular supernova. Its glow outshines entire galaxies, a reminder of the ever-changing landscape of the universe. The Earth and its cosmos, perpetually in motion, remind us of the impermanence of our journey. As we look at the star-studded canvas of the universe, we reflect on the trials and tribulations that lie ahead on our journey to the end of time. The hands of the clock move forward 1 billion years. Our sun, the source of all life, begins to change dramatically. Its luminosity increases by 10%, scorching the Earth with unquenchable heat. As temperatures rise, photosynthesis ceases by 1.1 billion years. The green carpet that once covered the Earth begins to fade, replaced by barren landscapes devoid of life. The air becomes thin, and the oxygen we need is depleted. The relentless heat is accelerating, and by 1.3 billion years, the Earth's vast oceans are beginning to evaporate. What was once a blue pearl in the cosmos is gradually becoming a dried-up brown. The great seas and oceans turn into mere memories. Our journey brings us to the last chapter of Earth's history in the 7.5 billionth year. The sun, transformed into a red giant, consumes our once lush planet, marking the end of Earth's existence. Home world, which has nourished us for billions of years, is now returning to the cosmic dust from which it was born. Fast forward to the year 10 billion. After its fiery death, our sun is reborn as a white dwarf, a weak, cooling remnant of its former self. From the raging hell of nuclear fusion, it's now just smoldering embers, a silent spectator to the grand cosmic drama that continues to unfold. By 100 trillion years, there's a deep silence over the cosmos. The stars, beacons of the universe, begin to go out one by one. They leave behind a chilling darkness, a universe in the twilight. By 1 quadrillion years, after the extinction of stars, the temperature in the universe drops. Having originated in the fiery origins of the Big Bang, we sink into cosmic winter, finding the universe gradually slipping into darkness. The era of starlight is over. The universe has become a cosmic graveyard. These are the last remnants of the stars that once illuminated the cosmos. They glow with a faint, ghostly light, a chilling reminder of the universe's fiery past. By 10 quadrillion years, these white dwarfs had become the dominant celestial bodies. This is the age of degeneration. It is a ghost universe that echoes memories of galaxies and stars that once shone brightly. The age of extinction is a vivid reminder of the endless cycle of birth and death in the universe. But even in its last gasp, the universe continues to evolve. Gravity, the sculptor of the universe, continues its work. Gravity, never resting, rips stars and planets from their orbits, hurling them into the cosmic void. These gravitational interactions sometimes lead to the birth of new stars, their creation heralded by ultra-bright supernovas. Echoes of the past universe. Meanwhile, white dwarfs begin to disappear. Over trillions of years, they cool and shrink. Their light dims until they disappear altogether. Dying white dwarfs are reborn as black dwarfs. A black dwarf is the final evolutionary state of a star. Invisible to the eye, they mark the plunge of the universe into darkness. The era of black dwarfs begins. The universe, once a spectacle of light and color, now a shadow of itself. The journey to the end of time continues in coldness and darkness. As time goes on, the universe continues its relentless expansion, each region of space stretching and thinning. Space-time itself is stretchy. What was once an organized whole now expands endlessly into something like a multitude of distant islands lost in a boundless ocean. But within this void, a silent catastrophe occurs. Protons, the building blocks of matter and life, begin to decay. Protons, the heart of every atom, disintegrate into ghostly neutrinos and photons. Matter as we know it is disintegrating. The universe is slowly erasing the last vestiges of its physical history. All that remains are particles of light and black holes. At this point in the journey, the familiar physical phenomena end, plunging us into a new era of cosmic history. We are in the era of black holes. Even the seemingly eternal black dwarfs have disappeared, giving up their mass to the unrelenting pull of the expanding universe. The last remnants of stars have turned into cosmic dust. Black holes are becoming the main, not the only, celestial objects dotting the universe. In an era dominated by black holes, the remnants of once living galaxies, supermassive black holes, are of particular importance. Born from the deaths of massive stars and the merging of smaller black holes, these celestial titans have grown to incredible sizes, absorbing matter and energy on a scale beyond anything we could have imagined. These cosmic events emit gravitational waves, causing ripples in the fabric of space-time. We can think of them as the last sounds of the universe on the verge of its end, the slow ringing of a bell echoing through the vast cosmos. Such outstanding objects of the universe as black holes are not as eternal as one might think. At first glance, the famous physicist Stephen Hawking in the late 1970s introduced the concept, now known as Hawking radiation, the process by which black holes lose energy and, therefore, mass over time. This phenomenon is a result of specific properties of quantum physics. Near the event horizon, where pairs of particles and antiparticles appear, one of the particles is sucked into the black hole, which helps the other to break their bond and escape into space. This leads to a net loss of energy and hence the mass of the black hole. Over enormous timescales, this slowly causes the black hole to lose mass and shrink. In this process, its once overwhelming gravitational pull slowly weakens. The result is the evaporation of a black hole. Such events mark the death of the last major objects in this universe, leaving behind a vast, seemingly endless cosmic void. Since the Big Bang, our universe has been expanding under the influence of a special force we call dark energy. A hypothetical form of energy called dark energy is believed to permeate all of space and act as the antithesis of gravity, causing the expansion of the universe to accelerate. At the same time, dark matter, which makes up 85% of the matter in the universe, creates gravitational attraction, acting as a counterbalance to this acceleration. Although dark energy seems to be the dominant force at present, we must consider the possibility of a shift in the balance of forces. There are several theories suggesting that it is likely that more dark matter may emerge as the universe expands, slowly increasing its gravitational influence. If the gravitational influence of dark matter exceeds the force of dark energy, the expansion of the universe could begin to slow down and possibly even reverse. This is comparable to the elastic band effect. The universe stretches more and more before the moment of abrupt contraction arrives. This process is also known as the Great Contraction. Great compression will inevitably cause the universe to collapse in on itself, the density of matter and energy to increase dramatically. At some point, we reach the critical point of this compression moment of peak density and temperature. Everything existing would be crushed into an infinitesimal point. In this extreme state, the fundamental laws of space and time are distorted beyond recognition. It is here, in this singularity, that another Big Bang could occur. Such a cataclysm could begin the birth of an entirely new universe, a new cycle of continuity of existence. This journey gives us a sense of our place in the cosmos. We realize that our existence is but a brief moment in the grand timeline of the universe. The journey to the end of time brings us to the very beginning, and perhaps this is where we find the greatest revelation. In a universe of infinite possibilities, the end is just another beginning.